Okay, good afternoon. I hope you are sitting at different places. Separate, please. Thank you. And I just got to make sure I get you guys to see the PowerPoints. Okay, so we're moving now towards C. And one of the key aspects of C and structured programming is the use of functions. So in structured programming, functions is a key thing that we need to learn. Just as in object-oriented programming, you need to know how to use objects. In structured programming, you need to know how to use functions. So our format for today's class, is we'll first of all run through the first try for milestone 2. Of course, if you have not done milestone 1, you need to do milestone 1. So please tell us. And then we'll walk through the solution. After that, we should hopefully have a short break. Then we'll start talking about the theory of functions. I hope to spend about 30 minutes doing that. We'll do a little bit of review again on compiling, linking, running, and debugging a program. And we'll quickly review that. You'll write and compile a short program. We will then break for another 10 minutes, and then we'll start to apply, going from UML to deciding the functions you want to use in your program. I hope we will be able to complete this. I'll first demonstrate doing it with following objects. Then we'll basically work through together in optics, and then you'll do it yourself with root finding. Okay, so that's basically our plan for today. So let's get started. We'll start with the milestone number 2, and our TAs will hand out the milestones. Okay, let's start walking through this example. And okay, so if I'm looking at this correctly, we will start by, obviously we need to start with our start indicator. If I can get, okay, start indicator, okay. We will then have a down arrow into our, or whatever arrow we like. We can go down, out to our next step. Our first step is we need to input the key, okay. So action would be input key. All right, and we can connect that to this guy. First thing we want to do is input the key. After that, we start to read a number from a file. Okay? So our next step is reading from the file. Read, I don't know, I'll call a number, let's call it X. I'm going to read X from the file. I then check. So I've got to have this is going to be part of my loop. So this guy has got to come into here. This will come to here. And we'll have a check. It says if we have not equal to 1 or not equal to the key, go to 2. Okay, let's just quickly do the go to part, and then we'll put in the conditions in a second. Okay, this is a looping structure, so we only need one diamond. Okay, moving up. Oops, this is not connecting right. Okay. Okay, so I've gone that way, and the other one I'm going to need to come out. Okay, so at this point I've got a condition coming out at this side. I know that when I finish my loop, I've got one of two things is true. Either it is I've read x equals -1 or x equals key. So I've got one output. It's going to be one of these two things is true if I'm exiting the loop. Okay, and I would continue on. Okay, now I've got another if. Okay, if, and it's an if. So it's an if statement, if x equals key. So I'm going to have a pair of diamonds sitting here for both conditions. So I'll have this guy come out, and then after we finish the two diamonds, we're going to go to the end, and I'll worry about implementing the conditions in a second. There we go. He can sit there. Oops. Okay, yep, he's nice. Okay, good. All right, so I've got the two situations. I'm going to print found, or the alternative is I'm going to print not found, right? I'm going to print one of those two things. That's basically all I'm asking you to do for my algorithm. So let's click, so I can now draw the output, guys. Let's make a nice arrow here. I'll send it just straight through. And come on, I see my mouse is not working that well. Okay, he go to here, he can go to here. Move this to here a little bit, move this guy over a bit. Whoosh. Okay, I'm gonna need another for coming out. Okay, let's get all these little arrows in now. One arrow. Two arrows. Okay, and then this guy's gonna, he should be straight line, right? Okay, I'm gonna put him here. This guy should be arrow, not straight line. Oops. Okay, switch him into an arrow. Shape outline, shoo. Arrows, okay, add an arrow. Okay, and the other guy, D, let's make him an arrow too, going this direction. And all I want is a line here. Oops, too long. Okay. Okay, and let's go. Okay, so in this case, if we printed not found, we have to put in one condition. So on to tell which way I'm going. So this is just going to be x equals -1, I think is a simple way of doing it. Okay. All right, so this is basically the complete diagram. You can see how we are showing the loop. It is a single diamond. The arrow comes in before the read x, and we keep reading. We should that if we get x equals -1 or x equals key, if it's not that true, we keep going. If it is, we continue here. Then we have an if else. If x equals key, we go this route, and we never go this route. If x equals -1, we go this route, and then we have to re-merge. Once we merge, we can then end. Okay, so it's very important that you have the if statement. It's an if-else statement, so it's got two diamonds. The while statement only is a single diamond. All right, and we probably should, although it would be good to start with a comment at the very beginning. But I'm not that specific on that, but it would be decent if you could put a comment there, basically to state that file is last line of file -1. Last line file is -1. Okay, so that's basically stuff that we are assuming when we come into this program, is that the last line of the file, because we say the last number of the file is -1, so we should probably put that into a comment line saying the last line of the file is -1, so that anybody looking at this algorithm realizes the file must conclude with a -1. Okay, is there any questions with that? So, okay, sorry, now that I'm doing this, I can just switch it now to final. Okay, there we are, and then I would then complete my complete cluster, nice standard. We'll get rid of this junk, get rid of this stuff that we don't need anymore, and I just say cluster, okay, not cluster, UML for search, linear. Okay, and okay, that's basically what we have. I'll just save it, and if you want to look at it, we can probably post on Portal. Okay, save as this PC. Let's search, browse. I'll put it right in my main directory. Linear search. Okay, is there any questions with this so far? We're okay on that? Okay, good. All right, I want to now, if you are looking at it and you want to follow along with the course, please remember our website, www.sdba.info. I'm hoping you're becoming quite familiar, hopefully will be. We're working on the basics of C programming. You've seen the installing stuff here, and you also know that we have, if you want to practice, we have the little blackboard for doing the PowerPoints. We also, in basics of C programming, so if you look, you have lecture 1, we have the course introduction, view graphs, the link to compiling editor, and the link to milestone 1 that we did. Last week we did a review, compile, link, run, debug. You can click here for the link, understanding the problem, the general PPTXs. Here you can click for Rahim's video on lens theory, Rahim's video on bisection method. Here's how we specified the problem for the graph following object, specifying the problem for optical lenses, specifying the problems for root finding. These are the PPTs are here. This is for reading. You were asked to read section 1. This is a link to the YouTube that Alec did to help introduce my UML diagrams. There's the PowerPoints for my presentation for UML diagrams. And there's our sort of our application ones. These are the PowerPoints, how we apply to the gravity, the falling object problem, the lens problem, and our final is the root finding problem. So today we are now in lesson 3, which is basically, okay, so lesson 3 on functions. So we have lesson 0, 1, 2, and now we're lesson 3, and we're basically class 4. All right, so today will be, let's move now to our view graphs for that. Okay, the theory of functions. This is what this set of view graphs will start. Probably do the first 10 minutes of this presentation, and then we'll continue on. Then we'll have a break, and then we'll continue on with the remaining 20 minutes of the presentation. Okay. The purpose of the functions. Okay. When we are writing functions, our key goal in functions is that each function does one task. In other words, when you write a function, you're assigning it one task. So each function does one job. It's not supposed to do different jobs, so that when you read the program, you can say, oh, this function is getting input. Oh, this function is calculating an average. Oh, this next function is going to calculate the derivative. This next function is going to do the output. So each function has one job and hopefully to do. Okay? The goal is divide and conquer. This is a British idea in which you try to split up. Okay, for example, Let's look at Malaysia, for example, as an example of using divide and conquer in real life. Okay, when the British took over Malaysia, they made a law. If you were Malay, you had to be Muslim. If you are Chinese, you must be Buddhist. If you are Indian, you could choose between Hinduism and Christianity. Okay? But you could not be a Buddhist and you could not be a Muslim. Why did they do that? Divide and conquer. That way the Malays and the Chinese could not unite against the British. Each of them were separate. They tried to do the same thing. So this is a British strategy when they were taking over countries and colonizing them, to try to divide the people into different groups. Okay? And therefore conquer. So similarly, well, not exactly similarly, but we want to use divide and conquer so we can attack a problem. We want to break it into smaller problems, and then we solve each of the sub-problems individually. This allows us, in a large person project, to divide each, so have one person in charge, and everybody else, and he can divide and say, okay, you do this part of the project, you do this part of the project, you do this part of the project. Your function, you should be able to get this information. Your function should give me this information. Your function should give me this information, and I will give you this information to do your calculation. So you can see from this bottom diagram here, basically, the idea is we have a project coordinator. In C programming, that project coordinator is called main, and then he calls functions. So one function could be written by, say, Andy, another function by Johnny, another function by Theta, another function by Brian. Anybody who's writing a function doesn't care what, so Andy does not care what Johnny's doing. Andy does not care or know what Theta's doing. Andy does not care or know what Brian's doing. Okay? This allows each person to concentrate in one area and not, okay. So this also avoids being, and if you write a function, you can then reuse the same function and avoid repeating work. So this gives you a quick idea of the key purpose of using functions. Now, in C, we have a variety of, we can think of functions in basically categories of 1, 2, 3, 4 different types of functions. Okay. We have functions that are standard functions. These are functions that people have written, and then a committee decided this will be a standard function, and we'll put it into, so whenever anybody downloads C, they will also get this function. Okay? So this is done by a committee. Okay? So a committee of people come together, just like IEEE specifies standards for many different things. Similarly, a committee gets together every certain number of years and say, okay, we need this function. Okay, let's think of new functions to add to C and put them into the standard library. For example, earlier, C could only handle English and Western languages. Later, people added functions, said, okay, we need to handle Chinese. So functions were built to handle Chinese and brought to the committee and put into the standard C programming library. Okay, so anything that's in the standard library has been checked and made sure it works well. Okay, and then gets put into as a library, a standard function. A second type of function would be third-party functions. These you could download from the internet. In other words, someone else has written them and you want to use them. For these types of functions, there's no guarantee that they work. Someone else has written them, you hope that they will work, and you will try to modify and need to check. Another type of function you might want to write is your own function. Okay, that's functions you write yourself, obviously, and put in your own program. Now, connecting with, generally, main is unique. It is called by the operating system. It's the only function that will be called by the operating system. So the Windows operating system, when you start your C programming, it looks for a function called main. And that is where it starts running. So main acts as a conductor for all the other functions that are working together. So main may call a standard function. Now the standard function could call the operating system again to get other things. So a number of standard functions are designed to talk to the operating system and get information from the operating system. You might want to write your own function, and then C allows you to directly go to the hardware without going through the operating system. Okay? So other languages you cannot do this. I believe for a lot of Python, you are blocked from doing this for safety. From Java, they don't want you connecting directly to the hardware because, yeah, they want you to go through the operating system. Because with a C, you can now write programming and do your own hacking much easier because you bypass the operating system and you go to the hardware directly with your own functions. So these are the three types of functions that we will work with when we are writing a C program. We will always have main if we're using a Windows computer. If we're using Arduino, we will always have setup. It's called setup rather than calling main. Okay, just a different name. But it's one specific function's name. Okay, we are now at the point we would like to break. After the break, we'll come back to function anatomy. And we'll give okay, I will release the screen. Okay, so we will break for 10 minutes. Okay, let's continue. Hello. Okay, guys. Great. Okay, so what have we talked about so far? Our crucial issue is C is a language of functions. It's a structured programming language. We have a few different types of functions. Basically, it's just on who's written them. Standard functions, third-party functions, and your own functions. Oh, sorry. I did not share screen. Oops. I am recording, yeah. But I did not share screen. Okay. We talked about main being a unique function as it's controlled by the operating system and it returns control to the operating system. So the operating system basically comes in and out through here through your main program. Main function, I should say. Okay, which acts as a conductor. So what does a function look like? Every function should look almost the same when you're writing a function. First of all, your function should have a couple of comment lines. This is a complete function, but here's a couple of comment lines. This is for the human, not for the computer. So your comment lines can be /* and end with a *// /*, and with a //. And you can put your comment line. I suggest your first line be the name of the program, then when you wrote it, and your name. So the computer there will be no reading. This will be thrown away as soon as the program starts when you run it in the compiler, GCC-C, this line will all be thrown away. Okay, so it won't go any further. So it's for the human, not the computer. It tells the human about the program, and the compiler ignores it. So I suggest you use 2 lines to give the purpose, date, and the author of the program. So this is a suggestion by me. After that, we have the opening statement for the program. Or the function. This is the name of the function. In this case, the name of the function is main. What information the function needs to receive to do its job is put here. In this case, this function doesn't need any information to do its job. Okay? That's why I write void. Void means empty, nothing. At the very beginning, so there's the name of the function. This is receive nothing from the calling program. And finally, at the very beginning, what information is this program or this function giving back to whoever called it? So the main is called by the operating system. So main is going to give an integer back to the operating system. So in this case, I'm saying main, you're going to give an integer back to the operating system. Okay? So this first line is the opening statement. Next, there are some lines in the middle which actually do the work. What is the function trying to do? What information is all these lines will be in here. And finally, the last line of the function says go give control back to whoever called you, and this is the information I want you to give back. I promised in the header I was going to give back an integer, so in this case I'm giving back the integer 0. Okay, so I have to return something, whatever I promised to return. If I promised to return integer, I'll return an integer. If I promised to return a floating point value like a decimal point number, I would return a decimal point number here. So that would be the return of the function. So every function has opening statement, tasks to complete in the function, and then a return at the end of the function. Now let's look at some grammar. Okay, the grammar of C. Brackets. Brackets are used to begin and to end a function. They must be matched. Python does not require brackets. C requires these curly brackets, and they must be matched, the beginning and the end. Secondly, every statement ends with a semicolon, not a carriage return. So carriage return is for you to look at. The C compiler does not care whether you have a carriage return. It doesn't care about white space. So if you put spaces, you can put spaces wherever you like to make it look clear for you. C doesn't care. What it cares about is this semicolon and these two brackets. A lot of errors come by people forgetting a semicolon or forgetting a bracket. All right, now you know what a function looks like. Let's now look at how we want to connect functions. I can connect functions with my own functions, with others' functions, and with C standard functions. Each of the ways that connections have things in common and slight differences. Okay. In each case, for every function, we require three things: a prototype, a call statement, and a definition. Can we echo? Prototype. Try echo. Prototype. Good. Sounds nice. Right. One more time. Prototype. Call. Definition. Okay. Let's now look at what each of these things are. Okay. First of all, I'm going to connect to my own function in the file. Okay, so here's my main function, and I'm going to have my own little function. I'll call it myfunc. Okay. First of all, I have my function prototype. Okay, I have my function prototype. Okay. This is a message to the compiler. Hey, look for a function myfunc in this file. It's going to require a long integer from the caller, and it's going to give back a long integer to the calling program. So and its name is myfunc. Okay, that's the function prototype for myfunc. Next, next comes the calling statement right here. The calling statement to myfunc, okay, in main program. So main comes, it calls the function. In this case, it says transfer control to function myfunc. This is the call statement. Give myfunc the value 6. Okay, so I give 6 and I come into my function call. So I've got my function call. The third part is the function definition, right down here. So this shows what the function is going to do. It has its header, it has its return, it says it's going to return the j. So, and this is what the function is doing. It's adding, this j++ means add 1 to j. So in other words, if it receives j equals 6, it goes j 6, it adds 1 to make it 7, and then it returns the number 7 to the calling program. Okay, so there's our three parts: the prototype, the call, and the definition, all in one file. Okay, I see all three: prototype, call, definition, when I'm using my own functions. Now, if we connect to third-party functions, okay, I have some third-party functions here that JInLive.h is a third-party functions that I wrote that we're going to use a little bit in this course, and it contains 4 functions: getFixed, getFixedPrompt, getFloat, getFloatPrompt. Okay, so let's start. So this is an example. You can see here's my 2 comment lines, and I have and you don't see in my program either a definition or a function prototype immediately. The first line, include JInLive.h, says it's a message to the preprocessor. There is a function prototype in the file JInLive.h. So go to the file JInLive.h, you will find function prototypes. And you can see here I got 4 function prototypes. So now I've got prototypes for getFixed, getFixedPrompt, getFloat, getFloatPrompt. Okay, next we have the function call. The function call right here says transfer the function to getFixed. Okay, we transfer getFixed, there's the function call statement. Now you will note that you don't see a function definition anywhere. It's going to be somewhere else, but not here. So you're going to need to include the definition when you link the function. In other words, it's going to be found somewhere in JInLive.o, which is an object file. Okay, so you're going to be able to look for that when we find there. So it's going to be when we link. We'll see that. So when you're writing, you just have to make sure you've got this to tell me where the function prototype is, and I have to make sure this definition is available when I link my file. Okay. Third type is to connect functions with the standard library functions. In this case, here you can see FS standard, connect to standard. Okay. What do we have here? Okay. Okay. We see here this line, include stdio.h, is a message to the preprocessor. This is the location of the function prototype. It's going to be found in a standard C library file, stdio.h. Note the brackets are different. The brackets are different because it is telling you, hey, this file is been checked. There's going to be no errors in it. Okay? It's a standard. It's included. It's been checked by a committee. It's not someone wrote it themselves. So you make sure you have these angular brackets. Not, in the previous case, we had these quotation marks. This time we have angular brackets. And it will be found in the standard C file stdio.h. So if I want to look, I can find that file. If you want to find that function prototype, I can look and find this stdio.h. Let's go look at that. It's okay. Let's go to our. Okay. Let's find. Got to be C drive. This PC C drive. Okay, trying to find, here we are, it should be in include, right? Include, where will you say it is? Look, just a sec, I go, sorry, I gotta get it back to where we are, standard, include, okay, I'm going to find stdio.h, it's going to be down here, oh sorry, I'm not showing the screen, sorry. stdio.h, lots of H files here, but the one I'm using here is, here it is right here. I'm going to open with edit with Notepad. Oops, it shot over here, okay. And you can see this huge file, and I'm going to search for find f print f. There's going to be a function prototype in this file. Okay, and that's not it. Find next, find next. Here it is, right here. The function prototype in the file is sitting right in here, fprintf. Okay, so and we see a whole bunch of different print statements, prototypes here. We're only going to learn one, fprintf. The other ones are not crucial for us right now. Okay, so we can do everything with fprintf that we need to do. Okay, moving back to our connection of functions. We have, it's located here, and we have our call statement. The function call, here fprintf, in this case the function call requires two pieces of information. Fprintf, the function call requires where I want to print it. That's going to be standard out, which as we saw is the monitor for the Windows system. It's the monitor. And what do I want to print? In this case, I want to print the word hi. So I put that I want to print. So that's the function call. It gives the function fprintf the information it needs to do its job. And the function definition, it's not here. But we need to make sure that a file stdio.o is available when we link our program. So once we've connected, so in other words, reminder, every function needs a prototype with the exception of main. If we don't write one, we need to tell the processor where it is. That's what the hash include does. It tells the C processor the function prototype is where you can look for and find it. Okay. Next, we have a function call. Every function will be called by somebody else, except for main. And we have a function definition, and if we don't write the definition ourselves, we need to give an object file with the function definition to the linker. So in this case, I've written my own function definition, but if I don't write, I have to have an object file with the definition in it, available when I link the program. Okay? That's how we connect functions. Now, when we go to the compiler, when we compile our functions, okay, if I'm just using my own function, it's very simple. gcc -c -wall myprogram.c. That's the compilation. If other files are not compiled, okay, if we have third-party functions, we have to also compile them if they are not compiled. If the third-party functions are not compiled, we need to make sure that we compile them. If there's no object file, usually there will be. Usually there will be a .o file for other people's programs. They don't give you their C. They usually give their object file. Okay? And we need to, each file we compile independently. Now, if it's a standard function, those functions are already compiled and we don't have to do anything. Okay? So there's nothing for us to do. When we link, remember the next step was linking. We compile, then we link. GCC -o, myprogram.exe, myprog.o. There's only one file, we don't have to link to anything, and all this is doing is renaming .o to .exe. Okay? That's a case in which there's no third party or no standard library functions. If we're linking to third party functions, we have to have GCC -o, myprog.exe, mprog.o, and for example, jinlib.o. I have to include the object file of the third party people stuff. So I've got my own program function plus a third party function here that I need to link together. So I've got both of those. And the linker needs all the files. If I'm linking to standard functions, in other words, I got no third party, it's just my own function and standard functions. In this case, all I have to do is use my own file, and the linker looks itself. It can find fprint f.o by itself. It doesn't need you to tell it where it is because it's a standard function. It's automatic. Okay, so you don't have to bother putting stdio.o at the end. You don't need that. It's a standard function. And finally, we can run our programs either by typing myprog.exe or myprog. Okay? So I've gone through a fair bit of stuff right now. So in summary then, let's remember functions allow for divide and conquer to simplify our tasks, and they facilitate code reuse. They also facilitate, every program requires a function main or setup if it's in Arduino. If you're writing C program for Arduino, you need the function's name is setup, not main. Okay, slightly different. Every function requires a prototype, a call, and a definition. Each file you have in your project is compiled independently. GCC -c -wall f1.c, GCC -wall f2.c. And one of these files must contain a function main. It doesn't matter which one, as long as there's a main somewhere. Okay? After you've compiled everything, you must link them together. GCC -o, m.exe, f1.o, f2.o, and when you run them, just m.exe. Okay, and now let's go back to what we are doing next. Okay? We are now going to go to compile, link, run, and debug. You're going to look at your general concepts, page 23 in your book. Page 23 in your book. I can look at that. Okay, so what we're going to do now is you're going to open the editor. Make sure Notepad. You can see what you're doing here. You're going to type in the simple first program here. You're going to then we want you to compile, link, and run it. Make sure it runs. Okay? So you're on page 23, right? In your book? I think it's page 23, right? Yes. There's code here. You're going to enter the code into the computer. You are then going to compile, link, and run the code. We've looked through how to do it. Now we want you to do that. Once it's running, you're going to make mistakes, assuming you don't have mistakes already. If you type in everything correctly and there's no mistakes, you will then make mistakes and see what messages the compiler gives you to tell you what the mistake is. Okay, so I will now give you your computer screens back. Okay, and we'll work on that. Okay, sorry. Okay, sorry to interrupt you guys. We need to do, okay, I'm going to take control of your screen for a second. Sorry. Okay, to compile, you're going to need to grab one more thing from this. Okay, I see it. Okay, I got it. Okay, you're going to have to go to SDBA. Again, installing. You need to go to install MeanGeneW. You don't need to install everything. You just need to do one thing. Come down, 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 come down. Course specific files. This is one thing we did not, okay, you're going to have to click on it, which will download this small little file. You can then open the folder. Okay, you will then click on the zip file, select everything, Control C.
Professor, we cannot see.
Oh, sorry. Oh, I'm on the wrong screen. Okay, sorry. Download the folder. Okay, I'm back again. Download the folder. You're in the downloads. Click on the zip file. Enter it, then Control C. Go to this PC. C program MeanGeneW. Then Control V. And finally, just rename the directory SDBA. And once you've done that, you will see, oh, my NCC icon is here. Okay, so the NCC icon will appear. You also have JIN library and everything else there. Okay, so that will allow that to appear. Okay, sorry about that.
And they have to save the file here.
What?
They have to save the file here.
Save what file? Oh yeah, and make sure you save the file in this directory, MeanGeneW or SDBA. That will make it also more convenient. Hello, hello. Okay, let's get started again. Okay. All right. We went through the UML. Remember the following objects is a dropping with gravity. And we basically came up with this sort of a UML, right? Our first UML is we read H1T1, read H2T2. Then we needed to calculate the average. We also calculated the velocity, delta H over delta T. And then we saved or wrote down VNT. We noted that, okay, once we've done that, we noted that, yes, question? Hello? Question over there? Or a beautiful song? Okay, we showed how you would probably want to. You could make it into a loop, reading more data each time, you know, placing things in a difference. And then we'd repeat, we'd do the whole table. Once we did that table the first time, we could then read all the velocities and do the program to get the accelerations. And we talked about, we could then link it all together if we used arrays, but we're not concentrating on this now. So in today's class, we want to look at the core program. This is the UML core program that we have, which we end up saving just this part we want to work on. Okay, so let's close and we'll continue on. All right, implementation. Okay, the next step, once we've got our UML, is to start to say, what sort of functions do I want to use for my program? So I start with my UML and I need to decide functions. Obviously, I can make choices. I can write my own function to do everything. I can write my own function to read. I could write my own function to do, calculate C mean, T average. I can write my own function to save. Or I could use a third party, or I could use a standard function. So in order to demonstrate this, we'll look at using, myself, I would break this into functions maybe like this. Okay, I decide, okay, I'm going to use a third-party function, get flow prompt, to read H1 and T1. Okay, that's from jinlib.h. Okay, I'm going to write my own function to calculate the mean, that is the t average equals T1 plus T2. And I'm going to write my own function to calculate the derivative, c dy dt. And I'm going to use a standard function, fprintf, to save my information. Okay, so I decided I'm going to use a third-party function for one thing, a couple of my own functions, and a standard library function. So I decided my functions. My next step is going to be, how do I, okay, and note the functions cmean and cdy dt, okay, the function cmean, I seem to have, okay, the function cmean and function cy dt, I can use these for acceleration as well. Okay, so I can reuse these functions to calculate acceleration. Okay, so I'm now deciding my functions. Okay, this is definitely dying. Okay, all right, let's continue on. So I am deciding my functions. Now I want to write some pseudocode to show how I'm going to do this to help me as I start to do my writing. So I've already decided, okay, get flow prompt will be called by main, cmean, cydt will, so I'm get flow prompt will get these information in, cmean, dydt will do these guys, and fprintf will do the saving. Okay, so now I have to write pseudocode. So let's see, I go grab my notepad. If I find notepad, where are we? Notepad, where are you? Notepad++, here we go. Okay. Okay, let's put my notepad over here, and I'll leave this side on this side so you can see sort of what I'm trying to do on this side. On my notepad will be on this side. And I'm gonna new file save as. Okay, let's go down to this PC, local disk, SDPA. I wonder why it's okay on this machine. Okay, all right, but anyways, okay. Let's call it G3. I don't know, G3.c. Nice number. Okay. All right. So now I'm going to start to work on. Thank you very much, Rahim. Okay, let's get started now on thinking what I'm going to do. Okay, so for everything I need a prototype, a call, and a definition. Okay, so I start with my comment lines, G3.c, and this is just my UML to functions for gravity. And probably I can write just the date, John, or 2503, or 11, I don't know what date is it? 10, okay, 10, John. Okay, all right, so I'm going to need function prototypes first. So I'm using get flow prop, which is third party. So I need to find the function prototype for that will be in include. And it's going to be in jinlib.h is where the function prototype is. Let's check. File open. I got jinlib.h. Yep, there's the function prototype right here. I'm going to use get float prompt. So there's the function prototype. It's in jinlib.h, so I just say include it. Okay, first function prototype is okay. Now I'm writing my own program for cmean, so I need a function prototype for that. So I'm just going to put a comment here. Cmean prototype. Just so I remember that I'm going to use it, I need it there. And c dy dt, c dy dt, prototype. It's my own function. I'm going to have to write one there. So I'm just now outlining the way my program is going to run. And I'm using a standard fprintf, so that means I have to include. Note that it's a standard library function, so it's going to, stdio.h, angle brackets, because it's a standard guide. Okay, I've got my 4 function prototypes here now, right? One from JNLive, one cmean, cdy. I've got placeholders for each of my function prototypes. Once I've done that, I can now have my main function. Integer main void. I'm not going to get any from the operating system. And my function will start. And it will end with a return 0. Okay, I first make sure I've got matching brackets. Okay, now I'm going to fill in the function. Okay, for main function, the first thing I want to do is I need a call get float prompt, and what I want from get float prompt is h1. So h1, I'm going to call get float prompt to get h1. I'm going to call, I want to get, okay, I probably can put it this way, h1 call get float prompt, t1 call get float prompt. You see I'm using my UML right here to see what exactly I need to do each time. Next I want h2 and t2, so I want to get those guys too. th2, I'm going to call get float prompt, and for t2 I'm going to call get float prompt again. Okay, now I've done this part. Now I want to calculate t average. So for t average, I'll just call c mean. Okay, and it doesn't matter the order, right? I've seen it doesn't matter whether which order I write. So in the function, when I'm doing this function, I make my decision. I guess I'll do this one first, I'll do this one second. So for v, I want to call c dy dt to get that. Okay, now I've got all my function. Oh, I forgot, I got to print stuff, right? Oh, I forgot that. Okay, so so then I want to use, I want to output v comma t average, and I will call fprintf to do that. Okay, so now I basically have all my function calls are here. You can see how main, what is main doing? Main is just calling functions. It's the conductor. It's not doing work itself. It's calling functions to do the work. Okay? All right. Now I need my function, okay? Prototypes, calls, definition. Okay. Now I want to make my definition for, okay, I'm going to have to define definition c mean, for example. And for my definition, I basically want to put down, I want to input. What do I need for the input? T1, T2. And I want to output T average. And my function is going to be T average equals T1 plus T2 is the equation divided by 2. So there's my definition for function C mean. And I would also I also need a definition for C dy dt. Okay, its input is, it needs 4 inputs, t1, t2, h1, h2. It's going to output, let's say it's outputting v, okay, and v, and the equation is v equals h2 minus h1 divided by t2 minus t1. Okay, that's the equation, and that was the end. Okay, so I can save this. So now I have my skeleton program. I'm now just going to have to, I know I've got my function prototypes will be up here, my function calls in main, and my function definitions for the 2 functions I am writing are here. I don't have to worry about function definitions for this guy, for get float prompt, or for fprintf, because other people have already done all that work. Okay, so this would be my G3 guy. Okay, so now, is there any questions? Any questions? C, dy, d, fifth line? Here? Oh, C, dy, dt. Oops, okay. All right, thank you. Yeah, okay. All right, yeah, correct? Okay, good. Okay, I'll save that. And we will upload this as an example for you guys, so you'll be able to see this code on the web. You'll be able to download it from the web. You can, or at least one version of it, maybe a different version. Each time I do it, I'll do it slightly differently, but it will be a version that you can download. Okay, let's move on for your guys now, your chance to work and try. I'm going to look at, okay, I want to go, let's do the optic one next. Okay, O3, okay. All right. Optical ray tracing. We talked about getting a UML there too, right? We went through it, we got this UML. Input O, F, and H. We then calculate I, the image position, by multiplying O times F and O minus F. We then calculate the position of, the height of the image based on the height of the object. Okay, sorry, there's a mistake here. This should be an O, not an I. Okay, sorry about that. Okay, by the height of the object. And then I output the image position and the height of the image. I now have to decide, where do I want to use third-party software? What would I like to use? When do I want to use my own? When do I want to use standard functions? So in this case, I look at this and I'm thinking, okay, input and output, I don't write my own functions for. That takes too much time. Enough people have done input and output functions. It's a waste of time for you to spend time writing those functions. Use somebody else's function. So in this case, I decide to make my choices. My suggestion is basically use get float prompt to get the input things. All the input, I'll use get float prompt for. I'll write my own function equation lens. I'll write my own function CMag, and I'll use the standard output function fprintf to output I and hi. Okay, so this is what we're going to be working on now. I would like you to, just as I did with the gravity one, I'm going to give you some time to work on doing this with the optics one, and then for homework, you'll be doing the root one. Okay, so writing the pseudocode for root. We can go to, I'll go to the website, and you'll be able to see, and when you go to the website, again, oh, I don't want to be here, I want to be back at basics of C programming. Okay, you can look at the, so the okay, we're going to be doing this. The UML will be here. You can click on the UML for this one and for R3. So here's the UML. There it is. So you can just sort of put it on the side of your screen so you can reference the UML as you write your, there's my UML. I put it here, and then I probably use Notepad to on the other side as you start to work on doing your doing the this similar sort of thing using Notepad for this optics one. Okay, and we'll take that up just before we probably at about 1 minute to 5 o'clock. We'll take that up. Okay, so I'm going to give you freedom now to work on that on your screen, and you'll be uploading it to Portal when you're finished. Okay. Actually, probably better to work on next week. Or you go to our website, website's also, you see the example. Yeah. 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 Well, this one for, after that, this is the flow that you get from. Okay? So that's what we find, I'm not ready to say. All of someone's already ready to go. Someone's already ready to go. Someone else doing it. Nail and shit. Nail and shit. No, not Okay. All right.
Angie, you don't know this. Can I talk? Amy, you don't know.
Okay, you are free to, okay, hello. Okay, you are free to leave. 什么时候你希望离开，你都可以离开。如果你还要歇一下，也可以歇一下，都可以，两个都 OK。